So, from the last lesson, we learned all about what are whole expressions and the concepts of them. We learned about polynomials and monomials and their relationships together. We also identified their attributes and also did some classifying. So, in this lesson, we are going to be learning something about combining like terms, which would be the first little section of our whole topic, simplifying polynomials. And that sounds exactly what it looks like. We simplify a polynomial. And we will also have parts 2 and 3 following. So what are we waiting for? Let's get started. The learning goals for this lesson is 1. Feeling the necessity of combining like terms in specific situations and understanding the operation laws based on the laws of combining like terms. And 2. Understand the rules of combining like terms and being able to combine like terms. That is the goals we are going to reach for today. So one is feeling the need to combine like terms in certain situations and understanding the concept of combining like terms, being able to, and understanding the rules of it. So introduce us to this new class that we're going to be starting. First, take a look at this picture. Think about what is the order of the medicines in the shop is placed. These are all medicines. And how is the medicines organized? What about this grocery store here? What is the order of the items in this grocery shop being organized? Is it all over the place? Or is it in some pattern, in some classifying? Now I'm going to ask you a question. If you have a jar of coins and there's all sorts of money, coins and money in there, like dimes, pennies, anything, how would you count them? In any way, how would you count how much money you have, or how do you count the coins you have? I'm guessing that you would probably do it like this. You would probably organize all dimes together, pennies together, dollar bills together, and nickels together, and quarters together. All of those being organized into nice groups, and then you would probably add those up. That is what I'm probably expecting from you. Now we're going to look into the concept of what are like terms. So I'm going to give you some examples of monomials, and then I want you to group them into different categories. So here are the monomials. 6x, 4ab squared, negative 3x, 1, 0.6ab squared, and negative 4.5. Pause the video, and on your notebook or piece of paper, write down how you would organize them into categories. How did you organize yours? Maybe you organize it like this. Negative 3x and 6x together, 4ab squared and 0.6ab squared together, and 1 and negative 4.5. How did this person organize it? Why and on which attributes? How did you group them? Explain. So you could just write it down on a piece of paper or write it in the comments down below. But that is not required, and you can actually group them in any way you'd like as long as it makes sense. And there is no correct way. So you might have organized it like this, maybe you haven't. But just write it down and then maybe explain. So how did this person group them? The variables were the same. Let's look back at here. These variable parts were the same. 6x and negative 3x. They didn't just look at the coefficients, they looked at the variable parts. The variable parts were both x's. 1 and negative 4.5 didn't have any variables, so they were in one category. And the last two terms, or monomials, they had the same variable part as well, ab squared. So the variable parts are the same. The degree and variable of the term are the same. So the degree of the variables and the variables were the same. Basically, terms that meet the two conditions above are called like terms. So what this is saying is that if you have multiple terms, I'm just going to give you two examples right here. Say you have 6xy squared and z cubed, and you have a negative 123xy squared z cubed. These are considered like terms. Like terms. They are considered like terms because their variable parts are the same. They both have x, y squared, and z cubed. This is what we call them like terms. The variable parts are exactly the same. Now, I want to give something clear also. So here we have the variable part xy squared z cubed. Now I'm going to give you another term. Negative 10 z cubed x y squared. Are this a like term with both of these terms? On the first glance, you might say no. After all, they don't look the same. But watch and think before you make a decision there. Is it exactly because they have to look alike? Or is it just a definition and meaning? They don't just have to look like. I mean, you could just switch these up into negative 10 xy squared z cubed using the commutative property of multiplication. You can switch those factors around and the value would still be the same. So which makes them terms as well. So that is a very important part you need to know. Because on tests or when we're practicing the concepts, they will come across this type of problem a lot. So you have to have that in mind. It's not just the looks, but the true values. See if you can switch those factors up a little bit until you can get them to look the same as the others. So these are called like terms. Pretty nice so far, right? Let's move on. So we're going to play two games. This is game number 1. It's called Finding Friends. So how we're going to play is I am going to give you a total of 8 monomials right here for you to sort. And you're going to help each term find friends. How do you do that? All you have to do is find the like term or terms of that monomial or term. And that is how you will help it find its friend. You can write your answer on your piece of paper or notebook and then unpause to find the final answers. So the first term, negative 5x cubed y squared. How would we do that? Well, what are the like terms of negative 5x cubed y squared? What other terms have x cubed y squared as their variable parts? Well, the second term is the same as the first term, so that makes them like terms. And then for 3 is x cubed y squared z. The same with 4. Look, that exact same scenario I just showed you came up. Watch. This isn't in the exact same order, but their variable parts would look the same if they use a commutative property in one of them and switch the factors around a bit, and then they would look more similar, but at the same time they're still considered like terms, whether the order is same or not. And then 5 and 6 are friends or like terms because they're both constant values. They do not have any variable parts. And finally, 7 and 8. They go along very well. They are friends and they're called like terms. They both have the variable part a cubed. So game number 2, and the title is called Like like/unlike terms. First, judge whether each group is like terms. If it's not, match one for the former. You have to choose and determine whether these pairs are like terms. But if they're not, you have to create a like term for each of those unlike terms. So what did you get? The first one, 2x squared y and negative 3x squared y. They're definitely like terms because their variable parts are exactly the same. The second one, no, they're not like terms. Mostly because this has an extra c being multiplied to it, while this is just 2ab. But if we gave it 3bc, that would be considered a like term. Third one is correct, and the PQ and QP could use a commutative property of multiplication to switch them up a little bit, and then they would be considered like terms. And the last one is not like terms. Negative 4x squared y and 5xy squared is not like terms. A like term would be x squared y. But let's look back here. This is another big mistake some students will have. So they see something like negative 4x squared y and 5xy squared. They have the feeling that exponents or powers are the same as multiplication and addition, and they can use commutative properties. But that's not how it works with the exponents. You can use that with multiplication and addition, but there is no such thing as the associative law or commutative law of exponents. That means you cannot switch those two powers around, which makes these unlike terms. Unlike terms are terms that are not alike. So x squared y would be a like term. So now we have a conclusion. These are all the rules of how to distinguish like terms. 1. Like terms are only related to the variables and their degrees, not to the coefficients and not to the order of the variables in the polynomial. It only looks at the variable part to which variables have which exponents. 2. Grasp the two identical. One is that the variables contained in it must be the exactly same, whatever the order, and that the index or power of the same variable must be same. These two conditions are indispensable. And 3, don't forget that several constant terms are also like terms. So if we have a constant term, it would be considered a like term. This is an example that I will walk you guys through. If 2a squared b to the power of n plus 1 and negative 4a to the mth power b cubed are like terms, then m equals blank and n equals blank. We remember that the variables that they have are both a, b. That is correct. But we're not for sure if their powers are the same yet. But it already told us that they are like terms. It already told us that. It already told us that they are like terms. So all we have to do is find out if they are the equivalent values between each of the variables' powers. That might seem a lot to you, but you'll definitely get it, and you will think it's so easy after I explain it a little more. Let's just first look at the variable a and its powers. For the first term, a is risen to the second power, or a squared. The second one, it's a to the mth power. But they are like terms. That means that their exponents has to be alike. That means 2 needs to be equal to m, or the other way around. So that gives us that m is equal to 2. The same with the b's. The exponent of the first b and the exponent of the second b in the second variable, they all have exponents. They just have to be equal. So from that we can know that n plus 1 is equal to 3. What plus 1 is equal to 3? 2 plus 1 is equal to 3. n is equal to 2. And if you plug them in and simplify it, you can see that in fact it is correct. And example 2. In the polynomial 6xy minus 3x squared minus 4x squared y minus 5yx squared plus x squared, the term without like terms is blank. It's asking you to find which term has not a like term. So which term cannot go in a pair? Well, let's just start from the first term, 6xy. Is there another term with the ending xy? No. So from that, you can already know that 6xy is the answer. But remember, do not fill in that blank yet. We always have to go back and look at all the other options, all the other terms, to make sure that we're sure of this answer. Well, negative 3x squared could pair up with positive x squared, and so it's negative 4x squared y and negative 5yx squared. Remember, you just have to switch those up there with the commutative law of multiplication. So the only one left is 6xy. So now let's look into the section combining like terms. First, I want you to look at an equation I have here. What do you see in that equation? What does it mean? It means 2 apples plus 3 apples is equal to 5 apples. Does that make sense? If you have 2 apples to your left and 3 apples to your right, and you put them all together into the middle, it's 5 apples. Now if we change those apples into x, 2x plus 3x equals 5 what? 2 of something called x plus 3 of the same thing called x is going to be equal to 5 of that thing called x. 2x plus 3x is equal to 5x. That is exactly the translation for combining like terms. Now let's try another one. 3 watermelons minus 2 watermelons is equal to 1 watermelon, or just watermelon. What if we turn that into a squared bc? 3 of something called a squared bc minus 2 of the same thing called a squared bc is going to give us a squared bc. Now, do you have any other ways to explain it? Can you think of any other way to prove combining like terms? Remember, combining like terms is just combining terms that are alike, like terms. Using the distributive property of multiplication, we can get, watch, this is another very helpful mathematical way to prove it. 2x plus 3x is equal to something x. How can we do that? We could do 2x plus 3x is equal to the sum of 2 plus 3 times x. If you think about it, it is correct. We can just factor out the x, which will leave us with this, the sum of 2 plus 3 times by x, which is equal to 5x. The same with another one. 3a squared bc minus 2a squared bc is equal to blank a squared bc. Well, we factor a squared bc out, which would give us the difference between 3 and 2 times a squared bc, which would just give us with a squared bc. Combining terms with the same variable part together is called combining like terms. Now I want you to do something. Take out your piece of paper or whatever you're taking notes with, and then jot these 2 ways of proving combining like terms on a brand new page and title it with Proving Combining Like Terms. This is something very important, and I would like to encourage you to think with the second distributive property way, because the first one is more visual, but this is more mathematical, and I want you to be able to think more abstractly. Okay, so pause the video as you do that. Did you really get it down on a piece of paper? Great, because we might be getting to some problems with it later on in this unit. Example 2. Simplify the following polynomials using the distributive law of multiplication. Here. So I am going to leave these two problems to you, and then after unpause the video and then share your answers. So the solution of the first one. Negative xy squared plus 3xy squared would just be the same thing as the sum of negative 1 and 3 times xy, which would give us 2xy squared. Also, over here, I actually forgot to add a squared over there. That's a 2. So yes, so the sum of negative 1 and 3 times xy squared, which would give us 2xy squared. And then the second one, 7a plus 3a squared plus 2a minus a squared plus 3. We first need to figure out which ones are alike. Well, we see that there's 7a and 2a and 3 squared minus a squared plus 3. For beginners, it's very important that you do this step first, or else it's very easily for you to get confused or be fooled by all of these terms going around here. So it's good if you have some sort of symbol or marking that will determine and tell you more clearly which ones are like terms and which ones are not. So as we can see here, this constant term 3 is the only term and it cannot be paired up with any other terms. So it's just at the very end. So basically we use the distributive property to factor the a's and the a squareds out. We simplify and that gives us 9a plus 2a squared plus 3. And example 3, combine like terms for all two of these expressions. So the same thing as last time. This shouldn't be too hard for you now, right? You probably already get the concept already. So here's a solution for number 1. 3a plus 2b minus 5a minus b. We find the like terms, which is 3a and negative 5a, and 2b and negative b. We're going to use a distributive property to factor the variable parts out, and then that gives us the simplified answer, negative 2a plus b. And second problem. Negative 4ab plus 1/3 b squared minus 9ab minus 1/2 b squared. You find like terms, that would be negative 4ab and negative 9ab, and another pair, 1/3 b squared and negative 1/2 b squared. You're going to factor them out, simplify the parentheses, then you get the answer, negative 13ab minus 1/6 b squared. Now let's have some sort of discussion. Is the following simplifications of polynomials correct? If it's wrong, explain. Again, since I can't really talk to you right now, it's your job to write it down on a piece of paper, maybe explain it to a family member or a sibling or a friend if they're around and you can reach them, or just write it down and then there are probably going to be some answers and I will reveal them. So these are the simplifications. Now it is your job to look and see if they are correct. Pause the video and do that. Now let's see here. Is the first one, a plus a is equal to 2a, correct? Yes, it is. 2 of something is equal to just 2 times that something. Second one, 3a plus 2b is equal to 5ab. No, in fact, they are not even like terms. You cannot combine them. It is not 5ab. 3. 5y squared minus 3y squared is equal to 2. Here is something that many students get confused with. They think that 5y squared here is equal to 5 plus y squared. Remember, this is not a mixed number. That does not work that way. This is multiplication right here. It's multiplication. That is multiplication. But how they do it is they think, well, this is 5 plus y squared, and then I'm going to subtract 3 plus y squared from it. And then if I remove brackets here, the y squares will cancel out, leaving me just with 5 minus 3, which was 2. No, this is a completely different example. You cannot think of this as addition, it's multiplication. Multiply things together. So that is incorrect. 4. 4x squared y minus 5x y squared is equal to negative x squared y. Again, that is incorrect. They are not even like terms. Remember, you cannot move these exponents around because they are not the same as addition or multiplication. 5. 3x squared plus 2x cubed is equal to 5x to the 5th power. No, they're not like terms. And most certainly, you cannot add exponents together unless they're being multiplied. But that's covered for a whole other unit. But you have to know that this are not even like terms and you cannot simplify it. And then there's 6. A plus a minus 5a is equal to 3a. What is a plus a? A plus a is equal to 2a. So it's saying 2a minus 5a is equal to 3a. Nope. 2a minus 5a would be equal to negative 3a. But negative 3a is not equal to 3a, which makes this last expression is also incorrect. Now here's the conclusion. 1. Search. Find the like terms in the polynomial, and different types of like terms are marked with different marks. For example, if you have a very simple polynomial like 8 minus 5 plus 7q minus 12b minus 6q, you have to, for example, like it's talking about different markings. Well, to mark them, you could be like, well, the constant terms, I'm going to mark them with straight lines. Terms that has q as the variable parts, squiggly lines. And negative 12b's, I will not give them any marks. So basically, it's going to be easier for you to identify them. So this is the whole process of combining like terms that we're going through right now. Second, shift. Using the commutative law of addition to move different types of like terms into brackets. So what's talking about here is like this 8 and this negative 5 is already next to each other, so we could just calculate that. But we need to move this negative 6q over next to the 7q and then calculate them. 3. Combine, just adding the like terms in the same bracket. So the ones that are next to each other or the like terms, you just combine them, and then that's your answer. Also add the coefficient. The variable and degree remain unchanged. When you combine like terms, it's not like you're going to change the variable parts. You just change the coefficients. The coefficients are what's being added or subtracted from each term. So it's not like after I subtract negative 6q from 7q, I'm going to get just 1. I'm going to get 1q or q because this q cannot delete this q. Remember, over here in between, that is multiplication. That's multiplication. So yes, that's a very important key point that you have to have there. Just add or subtract the coefficients, but the variable parts remain unchanged. It is multiplication right there in between, not addition. So there is some practice combining these like terms. So I'm going to leave these problem 1 and 2 to you. After, come back to me. So are you all done? I hope you did not miss out on any type of small mistakes. because we went through the whole process of combining like terms earlier on, and all you have to do is be careful and aware. Did you first mark them, and then did you shift them, and then you probably combine like terms? Let's see the answer to the first one. So we first moved the like terms into parentheses or brackets. So negative 3x is moved with 6x, and so is the same for all the other like terms. Then we simplify and we get 3x plus 3x squared plus 1. Then the second one. We move and shift the like terms into same brackets or parentheses. We simplify and then we get the answer, negative 12ab minus 12a squared plus 4. Example 4. Find the values of the following algebraic expressions. So over here, these are the algebraic expressions. And then among them, it's going to tell you the values of the variables. So the first one, x is equal to 1/2. And then the second one, a is equal to negative 1/6, b is equal to 2, and c is equal to negative 3. I am going to be curious to find out how you did this problem. There is a difference, and one way is much, much more harder than the other. So pause the video, start trying. Okay, did you get it? There's actually lots and lots of fun tricks in here. First, I would like to ask you how you did it. Did you first combine these like terms and then substitute this in? Or did you at first substitute the x in? Probably a lot of you first substituted x in. Well, what's going to happen is that it's going to be very hard to calculate. In fact, there is already a lot of like terms in here that you can combine, and then all you have to do is to put the x back in when it's in the simplest form, and then it'll be easier to calculate. For example, for the first one, watch. I don't even have to first care about what x is equal to. I first just try to combine and simplify like terms in the polynomial. 2x, there's positive x, 2x squared, there's positive x squared, and negative 3x squared. But if we add them together, they cancel out. We don't have to care about that anymore. And then there's negative 5x and positive 4x. That gives us negative x and then minus 2. Then we substitute this right on in when it's simplified. And then the answer would be negative 5 over 2. Now the second one. From chapter 2, you learn all about calculation and these important methods. When you were doing those problems, what were you told to do? You were told to first pause and observe the problem, not just going right in and starting to do it. Because if you follow that for this one, there is a lot of things, because if you dove into the problem once you saw it, you're missing out on a lot. First, 3a. 3a, there's also a negative 3a. We see that they're opposite numbers. Cancel them out. Next, we have negative 1/3 c squared and positive 1/3 c squared. Again, we cross them out. Now all we have to do is substitute the values into positive ABC. Once we do that, we multiply them, and then it would be 1. So yes, that's all you have to do if you first observed or first combine like terms. You don't have to just, on the first look, dive into it. Observe. Maybe you can find out some better way or easier or quicker way to do it. Remember, you didn't learn all of these operation laws like the commutative law, distributive laws in those areas. You didn't learn them for nothing. Use them. Take a time to remember what you learned in school and then use it. So now we have another discussion. If you don't know the value of a and b, can you find the value of this whole polynomial? If you can, find the value. If not, please explain why. I want you to try to figure this out. Yeah, figure it out. Do you have any fun ideas or fun ways? Is it hiding something? What did you come up with? Look, I am going to give you a helpful hint here, okay? Here is how I did it. I first observed the problem and I tried to find like terms. 7a squared. Are there other a squareds? Yes, there are. I'm going to mark them with a straight line. All the a squareds I am going to underline. And then for the b squared, I will do a triangle. Triangle on that one, that one, that one. Also, I forgot this one. Now, the ones that have a squared b. There are many a squared b's. I'll do I'll do a circle. Circle on that one, circle on that one. All I have is a -2 at the end. I'll circle it. Now we combine like terms. So if we do that, we can get 7a squared minus 4a squared minus 3 squared. Immediately, they cancel out. Next one. The triangles, which are the b squareds, are going to be -5b squared plus b squared plus 4b squared. Again, they cancel out. If you were just trying to solve it, you are missing out on a lot. Then the circles, 3 squared b and -3 squared b. They're exactly opposite numbers. Cancel out again. Now you see how only a little bit of observation could just lead you to something way less than you expected? All you have is the constant value -2. So really, we don't even need to know the value of a and b. It will always remain -2 because all the terms in which a and b are in will always end up being 0. So the values of a and b won't affect the value of the whole expression at all. So the result doesn't even include the values of a and b. That means it is a constant value, and its value will be constant and will never ever change. That value is -2. Now we have some practice in class. 1. If 5x squared y and x to the mth power and y to the nth power are like terms, then m is equal to blank and n is equal to blank. And then you have to combine like terms for all of these 3 polynomials. Pause the video and do all of these problems. After unpause to check your answers. Just like last time, we know that like terms, their variable parts has to be the same. Well, the variables are both x and y, so that is already clear. But we're still not exactly sure about their exponents. But since it has to be the same, m has to be equal to 2 because over here x is raised to the second power. And n has to equal to 1 because over here the y is raised to the first power. And then when you combine like terms, you'll get -4a, and then this would just be 0 because it cancels out. Then for the third one, it's ab squared minus a squared b. 3 and 4. Which of the following is like terms, and which of the following simplifications are correct? Like last time, do it yourself and then come back to check your work. So for the third one here, you just had to look at and kind of cross out or circle the ones that were like terms. So A, -2a and a squared. No, they're not like terms. They're not like terms. B, 2a squared b and 3b squared. No, you cannot switch around the exponents. C. 5ab squared c and negative b squared ac. Actually, it is like terms. You can just switch these orders around and then it will be like terms. Remember, we're not going to fill in that blank yet because we still have to look at D. Negative ab squared and 4ab squared c are not like terms. So the answer would be C. And 4. Which of the following simplifications are correct? Let's look at the first one. The first one is correct, but we have to also look at the other options. 3x squared and x squared. Remember, this is not addition in the middle. This is multiplication. That means you cannot cancel out, and then this is incorrect. B, the same thing. It is multiplication in between. That is also incorrect. And D, no, this is not even like terms. So A is our final answer. 5. Combine like terms in the following formulas. Combine like terms for these, and then after, come back and check your work. Did you remember the procedure of combining like terms? I hope you did. The first one is negative mn. Second one is 8a squared b minus 2ab squared plus 3. 6. Find the values of the following expressions. These are two expressions here, and I want you to calculate them. X is equal to negative 1 in the second one, a is equal to 0.1, and b is equal to 0.01. Remember, you first have to combine and simplify before you substitute in the values. Also, remember to first observe and then calculate. Okay, did you come back? X is equal to negative 1. We first combine like terms. You can see that many things here can cancel out. For example, the positive 2x cubed and negative 2x cubed. So the first one would be negative 10x squared minus 6x plus 3. But when x is equal to negative 1, you calculate. So the answer is negative 1. And 2. The same thing, you first combine like terms. And since a is equal to 0.1 and b is equal to 0.01, they will multiply together and multiply by negative 1, you will get negative 0.001. Now we have a look at problem 7. The water level in the reservoir dropped continuously for 1 hour on the first day, with an average drop of 2 centimeters per hour. On the second day, it rose continuously for 8 hours, with an average increase of 0.5 centimeters per hour. What was the total change in water these days? And 2. A store originally had 5 bags of rice, and each bag was X kilograms. Sold 3 bags in the morning and bought 4 bags of rice in the same packaging in the afternoon. How much kilograms of rice does this store have after the purchase? I want you to pause the video and do both of these problems, and then I am going to go through and then reveal the answers. Okay, so it says that the first one, it basically gave you how much times it dropped and rose and for how long. And then it also told you what type of change every time it rose or fell and what type of change that affected on the water level of the reservoir. All you had to do was add them up. Also, when you were adding, you had to remember to if it lowered, it's minus something. If it increased, it was adding something. Those were lots of keywords hiding in the problem. I hope you found them out. And 2. It talked about how a store originally had 5 bags of rice. So that was the original value there. And then each bag was X kilograms. That's 5X kilograms. And then you sold 3 bags in the morning, which is minus 3X, and then bought 4 bags of rice in the same packaging in the afternoon, so adding 4X. Then you calculate it. The answers were the water dropped for 1.58 centimeters, and the second one was now they have 6X kilograms in this store. Now we have class summary. We learned all about combining like terms, and we learned the concept of like terms. That was split up into two things. We also learned about the two sames or the two alikes. And what that meant was it contains two variables that are the same and the same power for the same variable. So if I had x in the first term and it was written and it was x squared, the second like term would also have x raised to the second power. And then two unrelated, which was independent of coefficient and regardless of the order of variables. So these has to be the same. And so there are two similarities between like terms that you have to know and two unrelatedness. So independent of coefficient, you don't even have to look at the coefficient, just look at the variable part. And regardless of the order of the variables, you don't have to look at what order the variables are in. They're just multiplication, and you can always use the commutative property to switch them up a little. So it is regardless of the order of variable. Now, lesson summary. The first goal we learned was to feel the necessity of combining like terms in situations and understanding the operation laws based on the laws of combining like terms. And second skill, understanding the rules of combining like terms and being able to combine like terms. So we learned the necessity and the concept. We also learned the rules and we were able to combine like terms. This is something that you will need lots and lots of practice with. So you will always need to be practicing. Get some practice problems. Try to use some sort of method from combining like terms in some problems you meet later on because you need to practice it. Also, here is homework for today. You are going to go back to practice. So the practice, and then I want you to pick out at least 3 problems and then I want you to redo it and explain it to a sibling, a family member, a guardian, a teacher, a friend, anybody that's around, and practice teaching how to do it. This will get it over your head again, and then you will get clearer and more confident with that skill. So go ahead, do that, then I'll see you for the next lesson. Remember, subscribe, comment, like, share if you haven't yet. And again, we'll see you next time.